In the 1970s, names like CB750, Z1, RD350, and Bonneville were more than just motorcycles. They were dreams on wheels. But then came the oil crisis when gas prices doubled, and new U.S. emissions laws threatened to silence them for good. What forced the motorcycle industry to abandon the icons riders loved and leap into a world of electronic ignition, fuel injection, and ride-by-wire? The transformation wasn't just technical. It changed what it meant to ride. This is the real story behind the revolution that turned 1970s legends into today's machines. The 1970s produced motorcycles that still stir the imagination. 4 bikes stood at the heart of this era. The Honda CB750, launched in 1969, brought 4 cylinders and an electric start to the masses. Its 67 horsepower engine and smooth ride made it an instant classic. Just 3 years later, Kawasaki answered with the Z1, a 903 cubic centimeters powerhouse that delivered 82 horsepower, enough to push past 130 miles per hour, making it one of the fastest production bikes of its time. Yamaha's RD350, with its lightweight frame and 44 horsepower 2-stroke engine, became a legend for riders who crave sharp acceleration and a banshee wail. Across the Atlantic, the Triumph Bonneville T120 kept British tradition alive, with its 1,200 cubic centimeters parallel twin, and a signature thump that echoed through city streets and country lanes. Riders remember these machines for their raw character. Every twist of the throttle brought mechanical feedback, clattering valves, the scent of fuel, and the sense that you were connected to every moving part. In a 1969 interview, Soichiro Honda summed up his vision. A motorcycle should be a 4-stroke engine that anyone can afford and enjoy. That spirit defined the era. These bikes weren't just transportation. They were symbols of freedom, rebellion, and craftsmanship. Owners tuned carburetors in their garages, swapped stories at roadside stops, and chased the horizon with little more than a helmet and a dream. The machines of the 1970s weren't perfect, but they made every ride an adventure, and their influence is still felt today. Gasoline prices soared without warning in late 1973. Within just a few months, the cost of oil quadrupled, and American riders faced fuel bills they'd never imagined. The Federal Energy Administration estimated that 500,000 jobs vanished almost overnight, and the entire country's economic output took a massive hit. For motorcycle manufacturers, this wasn't just a bump in the road. It was a turning point. Riders suddenly cared less about raw power and more about how far a gallon could take them. Small displacement bikes that could deliver over 90 miles per gallon, like Honda's C70M, flew out of showrooms. Engineers at Honda scrambled to squeeze more mileage from every drop, launching internal projects to redesign cam profiles and fine-tune carburetors for leaner running. But fuel wasn't the only concern. In California, regulators set a new hydrocarbon emissions limit of just 5 grams per kilometer for motorcycles, a number that spelled trouble for 2-stroke engines. These engines, once prized for their punchy acceleration, now faced extinction on public roads. At the same time, the Environmental Protection Agency in Washington capped motorcycle noise at 78 decibels, a level that forced manufacturers to rethink exhaust systems from the ground up. Suddenly, the mechanical symphony riders loved was being muffled by law. The pressure came from every direction, at the pump, in the legislature, and from the growing expectation that motorcycles could be both fun and responsible. The era of simple, noisy, high-emission machines was coming to an end. The industry had no choice but to innovate, setting the stage for a wave of engineering breakthroughs that would transform motorcycles for decades to come. The motorcycle industry's first answer to tighter emissions and fuel rules was a wave of hardware innovation. Engineers tackled the decline of 2-stroke engines by doubling down on 4-stroke designs, which burned cleaner and used fuel more efficiently. By the late 1970s, 2-strokes were fading from city streets, replaced by 4-strokes that could meet new hydrocarbon limits and survive the demands of daily commuting. Overheating soon became a new hurdle. Air-cooled engines struggled as power outputs climbed and emission standards tightened. The solution arrived in the form of liquid cooling. Suzuki's GT750, released in 1971, became the first mass-produced road bike with a radiator and a water pump, By the early 1980s, liquid cooling was standard on most sport bikes over 600 cubic centimeters. This change let engines run hotter and cleaner, squeezing out more power while keeping temperatures under control. Chassis and suspension technology advanced just as quickly. Steel frames, once the norm, gave way to aluminum twin-spar designs in the 1980s. These lighter, stiffer frames improved handling and made bikes easier to control at speed. Yamaha's introduction of the monoshock rear suspension in 1973 set a new benchmark for comfort and stability, and it was quickly adopted by rivals. Braking technology also leaped forward. Drum brakes, common in the early 1970s, gave way to disc brakes that could stop a bike in nearly half the distance. Side-by-side tests from the era show stopping distances dropping from over 60 meters to under 35 meters. On the dyno, power and efficiency gains became clear. Modern four-strokes delivered more horsepower per liter and used less fuel than their predecessors. Each of these changes laid the groundwork for the rise of electronics. But the revolution began with hardware, lighter, stronger, and undeniably faster. The arrival of electronics changed the soul of the motorcycle as much as any engine redesign. In 1967, a US patent described a new transistorized ignition system. No more mechanical points. No more fiddling with timing every season. By the early 1970s, Japanese engineers were building these solid-state circuits into production bikes, making spark delivery more precise and maintenance easier than ever. Riders could now count on their machines to fire up in the rain, at high revolutions per minute, or after months in storage. Fuel management soon followed the same path. Carburetors, once the heart of every tuning session, began to lose ground to microprocessors. Honda's 1982 CX500 Turbo became the world's first production motorcycle with programmed fuel injection. Its PGM-FI system used 7 sensors and a computer to meter fuel with a level of accuracy carburetors could not match. The result was cleaner exhaust, smoother power, and bikes that started on the coldest mornings with a single push of a button. By the late 1990s, electronic fuel injection was standard on most big bikes, making emissions compliance and performance gains possible at the same time. Throttle control evolved next. In 2006, Yamaha's YZF R6 introduced ride-by-wire to production motorcycles. Instead of a cable, an electronic sensor read the rider's wrist and sent signals to an actuator, letting the engine management unit fine-tune power delivery in real time. This paved the way for selectable riding modes, and eventually, for advanced safety systems. Anti-lock braking systems, first offered by BMW on the K100 in 1988 with help from Bosch, brought a new level of safety. The onboard computer could detect a locking wheel and modulate brake pressure in milliseconds, helping riders avoid skids on wet roads. Each of these breakthroughs, ignition, fuel injection, ride-by-wire, and ABS, shifted control from the hands of the rider to silicon chips and sensors, laying the foundation for the modern motorcycle experience. Manufacturers faced a crossroads as new technology and regulations split the market into distinct camps. The Japanese Big Four, Honda, Yamaha, Suzuki, and Kawasaki, chased global dominance through mass production, rapid research and development, and a willingness to adapt to every new rule. Their factories could turn out hundreds of thousands of bikes a year, each one ready to meet emissions, noise, and safety demands in markets from California to Europe. In contrast, European brands like Ducati and MV Agusta leaned into exclusivity, focusing on performance and heritage styling for a smaller but passionate audience. Meanwhile, BMW carved out a unique space with the R80 GS in 1980, launching the adventure segment. By the 1990s, adventure bikes saw double-digit sales growth as riders craved machines that could cross continents as easily as city streets. Racing also shaped the showroom. Homologation specials like the Suzuki GSXR 750 brought track technology to the street, blurring the line between race and road. The result was a fragmented market where scale and specialization both found their place. Electric motorcycles now stand at the edge of the industry's next chapter. Brands like Zero, Energica, and Harley-Davidson's Livewire have moved from prototypes to full production, offering torque that arrives instantly. Zero's SRF delivers 110 horsepower and a staggering 200 Newton meters the moment you twist the throttle. There is no engine vibration, no shifting, and no exhaust at all. On paper, these bikes achieve what seemed impossible in the 1970s: 0 grams of carbon dioxide per kilometer. Maintenance has changed too. Where a 1970s Honda or Yamaha called for oil changes every 4,000 kilometers and frequent valve checks, today's electric models go 12,000 kilometers or more between basic services, with many updates handled by software. The numbers tell a clear story. Modern bikes outpace their ancestors in power, reliability, and environmental impact, even as they redefine what it means to ride. Today's motorcycles are rolling computers, shaped by decades of innovation and regulation. As electrification and automation accelerate, the next revolution is unfolding now, not just in factories, but on every street. The ride keeps changing. The question is, are we ready for what is around the next corner?